Welcome, guys. Good day to you, and I hope you are doing good. You're welcome to our class for today. This is My Science Tutors Online, and this is your physics video tutorial. For today, we'll be discussing conduction of electricity through liquids, and we are going to be looking at electrolysis. All right, so please get your writing materials ready so that we can go to our class. But before then, if you have not subscribed to our channel, please subscribe. Click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, if you like what we are doing, give us a thumbs up, give us a like, give us a positive comment. You can reach us via the WhatsApp number that's showing on your screen, or you can put your comments on the comment section down below, or you can also join our WhatsApp chat group through the link that is showing below. Okay, so today our class is we are going to discuss electrolysis, and we'll look at what are electrolytes and non-electrolytes. We'll also discuss Ionic Theory of electrolyte dissociation. Then we'll also discuss types of electrolysis and the application of electrolysis. Then we are also going to discuss Faraday's laws of electrolysis, the first and second law of Faraday. Then we'll now solve some problems on the first and second law of Faraday's first and second law of electrolysis. Okay, so if your writing materials are ready, let's go straight to the class for today. You're welcome. Okay, so as I said, today our class we are going to talk about conduction of electricity through liquids. Conduction of electricity through liquids, and that has to do with electrolysis. So what is electrolysis? Electrolysis simply is the chemical change in a liquid due to passage of or flow of electric current through it. Okay, so when electric current flows through a liquid, the chemical change that takes place is known as electrolysis. Or electrolysis can also be defined as the chemical decomposition of an electrolyte in liquid or its molten state into its components by the passage of electricity through it. So when an electricity passes through an electrolyte, it decomposes. Right, so that process is what is called electrolysis. Okay, so that is a simple definition of electrolysis. Now, when you are talking about electrolysis, there are what we call electrolytes and non-electrolytes. Okay, so an electrolyte is a liquid or molten. When you say something is molten, a molten liquid is a liquid that is a little bit slimy, that is not too like watery, but it's a little bit sticky. So when you say molten liquid that is a little bit sticky, that is molten. Okay, so an electrolyte is a liquid or molten substance which allows passage of current through it and decomposes during the process. Okay, so any molten substance or liquid that allows electric current to pass through it and decomposes in the process is known as an electrolyte. Examples are acid, bases, and salts. These are good electrolytes, and they are also good conductors of electricity. Okay, then we have non-electrolyte. A non-electrolyte is a liquid or molten substance which does not allow passage of current through it. Okay, so you can see the difference between an electrolyte and a non-electrolyte. Example of non-electrolytes are kerosene, benzene, and paraffins. Paraffins are oils. These are also called poor conductors. Okay, they are non-electrolyte and they are also poor conductors. Okay, so also in electrolysis, there are what we call electrodes. There are what we call electrodes. An electrode is a conductor through which electric current enters or leaves an electrolyte. current enters through the positive terminal and leaves through the negative terminal. So take note of that. Okay, so the positive terminal is called the anode, while the negative terminal is called the cathode. Okay, so ions, these are charged electrons that either have excess electron or deficient electrons. Okay, so a charged particle that has excess electron or deficient electron is called an ion. Okay, so like a sodium atom that has lost an electron has a deficient number of electrons. So a sodium ion will easily lose its outermost electron to become positively charged. Okay, so a sodium ion that has lost an electron is an ion, and it is a positively charged ion. Alright, and then a chlorine atom that has accepted an electron has excess of electron, so it accepts electron and it becomes negatively charged ion. Okay, so that is what ions are all about. Then we have two types of ions. We have the cations and the anions. Okay, so we have the cations and the anions. The cations are positive ions and they are attracted to the cathodes. You don't forget that the cathode is a negative electrode. So the positive ions, they are attracted to the negative electrode. The anions are negative ions and they are attracted to the anode. Don't forget that the anode is the positive electrode. Okay, so the positive electrode is the anode and the negative electrode is the cathode. So what we've discussed so far is a brief introduction to electrolysis. All right. So we have an instrument that is used to study electrolysis, and that instrument is called the voltameter. Okay, so the voltameter is a device that is used to study flow of current in a liquid. It consists of the electrodes and electrolyte for carrying out electrolysis. So the voltameter is an instrument that is used to study electrolysis. Alright, so in the voltameter you have the cathode, you have the electrodes, and the electrode you have the cathode, the anode and the cathode. The anode is positive electrode and the cathode is the negative electrode. Then you have your electrolytes. Okay, then this is the container. So this complete setup is the voltameter. The complete setup is the voltameter. So before an electrolyte can conduct electricity, there's what we call Ionic Theory. Okay, something must happen to the electrolyte before it can conduct electricity, and that leads us to this Ionic Theory. We have said that the electrolyte is the liquid part or the mounting part of the components of the voltameter. So an electrolyte consists of positive and negative ions. Alright, so there are positive ions, there are negative ions in an electrolyte. Now the molecules that constitute the electrolyte will split in solution to the ions through electrolytic dissociation, irrespective of whether an electric field is applied to the electrolyte. So whether an electric field is applied or not, so the molecules of the electrolyte, they will split into their ions through electrolytic dissociation in liquids, whether electric current is passed or not. Okay, so when the electrode of a voltameter is connected to a battery, okay, so like in this setup now, okay, so this is your battery, this is a rheostat, and this is a key. So when the terminals of the electrode, they are connected to a battery as shown in this picture. A potential difference is set up, okay, so that the positive ions will move to the cathode, which is the negative electrode, and then the negative ion moves to the anode, which is the positive electrode, as shown in this particular diagram. Now, this directional movement of the ion constitute the current that flows through the electrolyte. Alright, so an electrolyte solution is able to conduct electricity because of the dissociation of the electrolyte in solution into ions. So as the electrolyte dissociates and the ions, they are moving to the cathode and the anode, and a stream of electricity is produced, and that constitutes what? The electric current that is flowing in the setup. Okay, so that is what the ionic theory is all about. That is what the Ionic Theory is all about. Alright, so I hope this is clear, and then we're moving now to different types of or examples of electrolysis. So examples of electrolysis, you have one, electrolysis of acidulated water. Electrolysis of acidulated water. In this electrolysis reaction, the Hofmann voltameter is used. For the Hofmann voltameter, the electrolyte is water that a few drops of sulfuric acid have been added to make the water more conducting. And then the electrodes for this particular setup is platinum plates. Now, when the process is set up, water dissociates into hydrogen ions and hydroxy ions as shown in this equation, while the sulfuric acid dissociates into hydrogen and sulfate ions. Now, when current is passed through the platinum electrodes in the acidulated water, hydrogen ions that are positively charged will drift to the cathode and they are discharged according to this equation. Then hydrogen ions will move to the anode and they are discharged with the formation of oxygen and water. So please, what you need to take note of is that in the electrolysis of acidulated water, at the cathode, hydrogen is deposited or discharged, while at the anode, oxygen is discharged. Hydrogen ion is discharged with the formation of oxygen. So please take note of these two equations. These are what primarily you should take note of in the electrolysis of acidulated water. Okay. The second type of electrolysis is the electrolysis of copper sulfate solution with copper electrodes. Electrolysis of copper sulfate solution with copper electrodes. In this particular case, the two electrodes are made up of copper, and the two copper they are immersed in copper sulfate solution. Okay, so the copper sulfate solution dissociates into copper ions and sulfate ions. Then the water breaks down into hydrogen ions and hydroxy ions according to these two equations that are stated here, according to these two equations. Okay, but when current passes through the electrolytes, both the copper and the hydrogen ion will move to the cathode. Now at the cathode, copper is discharged in preference to hydrogen, hence copper is deposited at the cathode, and this is the equation that represents it. Copper is deposited at the cathode. Alright, then at the anode, the sulfate ion and hydrogen ions, they will move to the anode, but also don't forget that copper is still in the solution. All right, copper remains in the solution. So in this case too, copper is discharged into solution over sulfate ion and hydrogen ion. So the copper too is also discharged at the anode. So this equation, this is the anode equation, and then this is the cathode equation for this electrolysis. And you need to take note of these two equations because these are what are always given in examinations. Okay, so take note of this one and take note of this equation. So you can be asked that in the electrolysis of copper sulfate solution using copper electrode, which of the following elements are discharged at the cathode or at the anode? That is a typical question that you can be asked. So you should know which element is discharged in any of the electrodes. All right. So this is another one too. This electrolysis of copper sulfate solution with platinum electrodes. The first one we discussed just now was with copper electrodes, but with platinum electrode during electrolysis, copper and hydrogen ions drift to the cathode and copper is discharged in preference to hydrogen. So you have this equation, but at the anode, hydrogen ion is discharged and in preference to hydrogen ion. Okay, so this is your anode equation, and then this is your cathode equation. Okay, so copper is deposited at the cathode and oxygen gas is liberated at the anode with reduction in concentration of copper sulfate in solution. So these are the different types of electrolysis, and then you have the different electrode, the different type of cathodic and anodic reactions. Okay, so I hope you are taking note of this because they are very, very important when you are studying electrolysis. All right, so that is about electrolysis. So what are some of the applications of electrolysis? What are some of the everyday applications of electrolysis? One of them is in electroplating. Okay, one of them is in electroplating. So what is electroplating? Electroplating is the process of coating a metallic object with another metal in order to improve its appearance or to safeguard it against corrosion or rust. Okay, so in everyday you make use of your spoon. If you look at your spoon is mostly silver coated. There are some that are golden coated, like golden spoons, but the general spoon that we use, they are silver coated. So how is that process done? How is that process done? We are going to discuss it. The process is actually done with electrolysis. Okay, so the process of electroplating other metals is carried out through electrolysis. So electrolysis is the process of coating a metallic object with another metal in order to improve its appearance or to safeguard it against corrosion or rust. Now, electroplating agents include we have copper, we have silver, we have chromium, we have nickel or gold. That is why you can see some metals, they are chromium plated, some are nickel plated, some are gold plated, you have silver plated, you have copper plated. These can be used to electroplate other metallic objects like spoons or cutlery are often coated with silver that we have discussed before. Okay, so how is this process done? How is the process done? Now, if you look at this setup here, like for the electroplating of a spoon with silver, all right, so the electrolytes, see, the electrolytes is there, then you have you have your electrodes. Okay, you have your electrode. Now for electroplating, the material to be electroplated is used as the cathode of a voltameter, which has an anode of the electroplating material. Okay, so what that means is that this is what you want to electroplate. So what you want to electroplate is what you put as the cathode. Then the electroplating material will be your anode. This is your anode. This your anode is the electroplating material, while the metal you want to electroplate will be your cathode. The electrolyte is the source solution of the metal to be deposited. Okay, so now you want to deposit silver. So in this particular case, your electrolyte is silver nitrate. Your silver nitrate is a source solution of silver. Okay, so since you want to deposit silver on the spoon, you use a source solution of silver. Alright, so a silver spoon is electroplated by using a silver nitrate solution and pure silver as the anode. So that's what I just said. Your anode is silver, the electrolyte is silver nitrate, which that is salt of silver, and then you have your the metal to be electroplated, which is your cathode. Okay, so the silver ions are drawn to the surface of the spoon, and the spoon eventually becomes plated. So once this setup is complete, when current flows, silver and nitrate ions are produced in solution. The silver will now drift to the cathode because it is positively charged, and it is deposited on the spoon while the nitrate goes into solution. Alright, so as the silver is drifting to the cathode, it is depositing on the cathode, and as it is depositing, it is electroplating the spoon. So by the time you finish the process, the spoon will come out silver plated, will be shining, and the appearance will be better. Okay, so that is how electroplating is carried out. Other uses of electrolysis: one is for purification of metals, like this electroplating that we just mentioned. It is used for purification of metals. It is used for extraction of metals. It is used for production of gases, and it is also used for calibration of ammeters. Okay, so these are other uses of electrolysis, but typically in your examination, this one is the number one: electroplating of metals. Okay, so those are the application of electrolysis. Now, this is a man that actually studied the process of electrolysis, and he came up with two laws. All right, so the first law of electrolysis by Faraday states that the mass of a substance liberated or deposited in electrolysis is directly proportional to the quantity of charge or the quantity of electricity which is passed through the electrolyte. And mathematically stated, mass is directly proportional to Q. Remember that Q is equals to current times time. So if you substitute current as time into this equation, it becomes mass is directly proportional to current as time. Now the constant of proportionality, which is Z, is known as the electrochemical equivalent of the substance. Okay, where Z is electrochemical equivalent of the substance, I is current in amp, and T time is seconds. Electrochemical equivalent can be defined as the mass of that substance deposited by 1 coulomb of electricity during electrolysis. So electrochemical equivalent is equals to mass per coulomb, and the unit is gram per C, or mass over current times time, or density times volume divided by charge. Don't forget that mass is density times volume, because density is equals to mass over volume. Alright, so depending on how your question is twisted. Then the second law of electrolysis states that the masses of different substances deposited or liberated by the same quantity of electricity are directly proportional to their electrochemical equivalents. So mass of A all over mass of B is equals to electrochemical equivalent of A all over electrochemical equivalent of B. So guys, these two equations are very, very key. That is this first one is equation 1. I will have labeled it as equation 1. Sorry about that. And this should be equation 2. I will have labeled it as such. So these are the typical key two equations that you need to solve most of the problems on Faraday's law of electricity. So right away, let's go and solve some problems. So this is question number 1, and it says that the mass of silver deposited on the cathode of a silver voltameter, if a current of 0.7 amp is passed through it for 25 minutes, is what is a objective question. Okay, so this is electrochemical equivalent of silver, and in this particular instance, we know that mass is equals to ZIT. Okay, so here your Z has been given to you. Your Z is given to you to be 4.5 times 10 raised to the power minus 4 gram per coulomb. You are be given I, which is current, to be equals to 0.7 amp, and you are be given a time to be equals to 25 minutes. So you have to convert that to seconds by multiplying it by 60. Okay, so what you have here will give you time in seconds. Okay, so having done that, you can now come and substitute into this equation. So our mass equals to Z, which is 4.5 times 10 raised to the power minus 4 multiplied by current is 0.7 multiplied by time, which is 25 times 60. Okay guys, so if you work this out with your calculator, you are going to have the mass of silver deposited will be equal to 0.473 grams. Okay, so this is just how to apply the equation. There's no difficulty in it, right? This is another question. This one says that a charge of 1 coulomb liberates 0.003633 gram of copper in an electrolytic process. How long will it take a current of 2 amp to liberate 1.98 gram of copper in such a process? This is also a jam question. Remember that M is equals to ZIT. Okay, so in this particular question, you are be given your Z. Remember that the mass of a substance liberated by 1 coulomb of electricity equals to what? The electrochemical equivalent. So if 1 coulomb of electricity liberates 0.0033 gram of copper, it means that this is the electrochemical equivalent of copper. So electrochemical equivalent of copper has been given to you because that is the mass liberated by 1 coulomb. Okay, so this is your electrochemical equivalent, and then your current is given to you to be 2 amp. Then your mass to be liberated is 1.98 gram, and then now you are looking for time. Say how long will it take? Time is what we don't know in this particular question. So from this equation, we can see that time is equals to what? Mass all over Zi. Okay, so substituting into this equation, you are going to have your mass is 1.98 all over your chemical equivalent is 0.0033 all multiplied by the current, which is 2. Okay, so punch your calculator, you will have 300 seconds as your time. So your time is equals to 300 seconds. If you convert that to minutes, you are going to have what? 5 minutes, because you divided by 60, so that gives you 5 minutes. Okay, so this is how to go about all these questions, right? So guys, this is your test your understanding page. Please go through these questions, solve them, the same method, the same formula, and solve them, get your answers, check your other textbooks, solve more problems on this topic so that you get a better understanding of what we have discussed so far. Alright, so this is where we are ending our class for today. But before I leave, please, if you have not subscribed, subscribe to our channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Give us a like, give us a thumbs up. Also invite your friends so that they can come and enjoy what you are enjoying. Alright, so thank you so much for your time. We appreciate you so much. Continue to be the best that you are, and continue to improve in your studies and your learning. We are here to support you. So if you have any problem, any challenge, please put it on the comment section or put it on the WhatsApp chat group platform. We'll go through it and then give a response to your questions or to any challenge that you have, right? So thank you so much, and remain be good. Yeah.